I'm sharing my screen. In the last class, we completed with the counters, no? So today we'll discuss about the shift registers. Okay. So shift registers, registers, shift registers are registers. What are the registers? So if you want to store some value temporarily, we'll use the shift registers. Okay. So shift registers, registers are shift registers. Registers are we can call as shift registers. Shift register. Okay. Shift registers. Uh, so if you see the shift registers, so we'll store the multiple. In order to store multiple bits of data, we'll use the shift registers. Okay. We'll store in order to store multiple bits of data. Okay. Multiple bits of data. We are using the shift register. Okay. Bits of data. We are using the shift register. Okay. So for storing n bit of data, we require n flip flops. Okay. N flip flops. Okay. So like basically counters counters we designed by using which flip flops, JK flip flop and T flip flop, that should be operated in which mode, toggle mode. Okay. So basically for registers we'll use this D flip flops. We'll use D flip flops. Okay. For registers you'll use D type flip flops. So data can be how the data is shifting. Data can be fed like serial. Okay, data can be fed serial. Serial means what? One bit after other. One bit after other. Okay, data can be fed serial. Okay, one bit after other. Or data can be fed parallel. Parallel means what? Parallel means all together at the same time. Okay, all together at the same time. Okay, at the same time. So means we can do the serial operation and parallel operation. Okay, so if you see this shift operation, so types of shift operation, there are four types are there. There are four types are there. Types of shift registers. Types of shift registers. Okay, one is what SISO. SISO means what? Serial in serial in SIPO. First we will see SIPO. SIPO means serial in uh, serial in serial out. We'll see. Okay, serial in serial out, serial out, serial in serial out. SISO, SISO, serial in serial out. And next is SIPO. SIPO means what? Serial in parallel out, parallel out. Serial in parallel. Serial in serial out is nothing but what? Whatever the data you are means you are loading the data serially, and the data will be shifted serially out. Okay, and serial in parallel out means what? The data will be loaded serially, and data will be taken parallelly at a time. Okay, that is nothing but parallel out. And next you have PISO. PISO means what? Parallel in serial out. Okay. PISO means what? Parallel in serial out. Parallel in serial out. Parallel in serial out. Okay. This is PISO. PISO. Okay. And next is PIPO. Parallel in parallel out. Parallel in parallel. Okay. Parallel in serial out means what? You can load the data parallelly at the time, and you need to take out the data serially one by one. Okay, one after the one bit after another bit. Parallel in parallel out means you can say, like you can upload the data at a time, and we can remove the data at a time. That is nothing but parallel in parallel out. Okay. So first we'll see serial in serial out. Okay. Serial in SISO we'll see. Okay. What is this SISO? Okay. So CISO. CISO means what? Serial in, serial out. Okay. So first we will see first one, that is nothing but CISO. Okay. Next is CISO. SISO. SISO means serial in, serial out. Okay. Let us take like three flip flops. Okay. Uh, Sorry, four flip flops. Okay. So let us take four flip flops. T3. You are using D flip flop, no? So for n bit shift register, okay, for shifting n bit of data, you need n flip flop. Okay. For shifting 4 bit of data, you need how many flip flops? Four flip flops are required. Okay, four flip flops are required. So here D3, Q3, D2, Q2, D1, Q1, D0, Q0. Okay, this is connected like this. Okay, it is connected like this, and this is serial in. We are inputting the data serial in and serial out. This is serial out. Serial out. Common clock is given to all the flip flop as this is a synchronous sequential circuit. So the common clock is given passage of clock. Passage of clock. So common clock is given. Okay. So now we'll see, we analyze this circuit. Okay, how this circuit will look like. Okay. So SISO, serial in, serial out. So I'm writing this one. One second. Okay. Yes. So here, if you see serial in, serial out, no. So I'm drawing the truth table. Let us take Q3, Q2, Q1, and Q0, and clock. Okay, this is clock. Okay. Let us take. I want to shift serially. Which bit means I want to shift like mm, 111. Four ones. Four ones I need to shift. Okay. First, initially, all the flip flops, the output of the flip flops are what? Zero. Okay. So output of flip flops are what? Zero only. Okay. All the flip flops are zero only. Okay. So that means when clock is, you are not applying any clock, the output of all flip flops are zero. Okay. So if you are applying first clock pulse, what happens? Whatever this data is there, this data will become to D3. Okay. So D3, and what happens? One will be come here, and zero will be there, zero will be there, and zero will be there. So that means one will come here. After that, you know that D flip flop is a sequential buffer. Whatever the input you are giving, you are getting the output. No, we already seen like Q1 plus 1 equal to for D flip flop D. No, next state equal to what D. Whatever the input is given, you are getting the output. So that will be shifted. Okay. So what you are getting at one first clock pulse, you are getting 100. Okay. At second clock pulse, what happens? At second clock pulse, this will be shifted. So that means this one will be given to here. So that means here one will come, and next here anyway zero are there, and one will be given to here. So that means here you are getting what? 110, 11, next 00. Okay. At third clock pulse. Okay. Third clock pulse, what happens? This will be shifted. Okay. So this will be shifted. So here 0 will be shifted, and 1 will be shifted, 1 will come here. This 1 will be shifted, 1 will come here, and this 0 will you are getting here, and one more 1 will be loaded. Okay. One more 1 will be loaded. Here 1 you are getting. Okay. So this is nothing but what you are getting 1 1 10, 1110. Okay, third clock pulse. Okay, at fourth clock pulse, what happens? At fourth clock pulse, so this will be shifted. So one will be shifted. So one will come here, and one will come here, and this one will come here, and one more data. Okay, so this last bit will be loaded, and here one will come. Okay, at fourth clock pulse, what happens? All the data will be loaded in the shift register. All the data will be loaded in the shift register. At which clock pulse? All the data. Suppose if you consider n bit shift register, n bit SISO. Okay. At what clock pulse all the data will be loaded means n clock pulse. all the data, whatever the data if you want to load, so at n clock pulse, the data will be loaded in the shift register. Okay. And next what happens? Next clock pulse. Next clock pulse you are applying a fifth clock pulse. What happens? This will be shifted. So that means this one will come here, and this one will come here, and this one will come here. Okay, this one will come here, and this one will come here. Whatever the vacant position is there, that will be loaded with 0. Okay, so here you will get in 0, 1, 1, 1. Okay, so this is at fifth clock pulse. Okay, at sixth clock pulse, what happens? At sixth clock pulse, at sixth clock pulse, mm, so here this will be shifted. Okay, this will be shifted. This will one will come here. This one will come here. Okay, and uh, 1 second. This one will come here. Here 0 will come. Okay, here 0 will come. Okay, 0, 1, 1, 1. And this 0 will be shifted. Here 0 will come, and here 1 will come, and 0 will be loaded. So here you are getting 0, 0, 1, 1. Okay, and next at the seventh clock pulse, what happens? At the seventh clock pulse, just I am seeing here. At seventh clock pulse, okay. At seventh clock pulse, here this will be shifted. So that means this will be shifted. Here 0 will come, and here 0 will come, and here 1 will come, and whatever here 0 will come. Okay, 0 will be loaded. At seventh clock pulse, here you are getting 0, 0, 0, 1. Okay. At eighth clock pulse, what happens? At eighth clock pulse, so all the content of so this will be shifted. Okay, so this will be shifted. This will go. Okay, so all the content becomes what? 0. All the content becomes 0. This will be shifted, and all the content becomes 0 at eighth clock pulse. At eighth clock pulse, all the content will becomes 0. Okay, so from here I can say that uh, so so at eighth clock pulse, so that means at 2n clock pulse, at 2n clock pulse, what happens? Uh, all the data, all the data of SISO, all the data of SISO will be cleared, will be cleared. Okay, will be cleared. Is it fine? Do you understood any doubt in this SISO? Your response so that I will move forward. Hello, are you there?
Yes, sir. Yes, sir, understood. You can go further.
Okay, okay, okay. Yes. Next you see. Next, what is that? Next, SIPO. Okay, SIPO. SIPO means what? Serial in parallel. Okay, SIPO. SIPO means what? Serial in parallel. So serial in parallel means same diagram. Just four flip flops are required. Four flip flops are required. So this is D3, Q3, D2, Q2, D1, Q1, and D naught, Q naught. Okay, so this is connected like this. Okay, this is connected like this. Okay, so loading of the data will be done serially. Okay, serial data. Okay, loading of data will be done serially. Okay, serial data. Let us take same data I am taking, and whatever the shifting operation is there, that is done in parallel. Okay, so common clock is given to all the flip flops as this is a synchronous sequential circuit. So common clock is given. Okay, so common clock is given. This is passage of clock. So during the passage of clock, all the flip flops will be triggered. Okay. So first I'm writing clock. Okay. Clock. Next Q3, Q2, Q1, and Q0. Okay. So When clock is not applied, uh, all the flip flops will be what? There will be some reset circuit also. So if you want to give some reset circuit, asynchronous reset you can give like here reset underscore n. So that means this is given like this. Okay, like this I can give. This is given to clear signal. Clear signal is a asynchronous input. Okay, so when clear signal is activated, what happens? Irrespective of this, whatever the inputs and clock, this will force the output to zero. Okay, so that means during that means I can say that you can add one more column. Okay, you can add one more column. So I'm giving one more reset underscore n. So when it is zero, so that means when clock is not applied, all the flip flops are zero. Okay. So when it is one only, then it will be in functional mode. Okay. So when it is one only, it will be in functional mode. Okay. So you are applying first clock pulse. Okay. So during the reset mode, all the flip flops will be what zero only. All the flip flops will be zero only. Okay, and next you are applying what first clock pulse. First clock pulse, what happens? This one will come here. Okay, this one will come here, and as this is a sequential buffer, you are getting the Q3 equal to D, whatever the input is there. So here you are getting one, and this zero will be shifted here zero. Okay, here next here zero, and here zero will get. Okay, so here you are getting one zero zero zero. Okay, and at second clock pulse, what happens? At second clock pulse, uh, so this one will come here. So that means this one will come here, and this is what this is zero only, and this is zero only. This zero will come here. Okay, actually shifting operation is happening, and this one will be loaded, and this one will come to Q3. Okay, so same as a SISO only up to loading of data. Same as SISO only. Okay, 1100. Okay, 1100. At third clock pulse, what happens? At third clock pulse, again this one will be loaded. Okay, this one will be loaded, and so here you are getting one. One will be shifted. Here one you will get, and here one will be shifted. Here one you will get, and zero will be shifted. Here zero you will get. So 1 1 0 one second 1 0 1 1, and this is 1 0 1 0. Okay, at fourth clock pulse what happens? At fourth clock pulse, so this will be loaded here. Okay, and next this so here this one will come here, and this one will be shifted. So here one you are getting, this one will be shifted, and this one will be shifted. Okay, this one will be shifted. Okay, so at fourth clock pulse what happens? All ones you will get, all ones you will get. Okay, so that means at fourth clock pulse itself, at fourth clock pulse itself, what happens? At fourth clock pulse, here at a time you are taking 4 bits of data. At a time you are taking 4 bits of data. So this is what Q3, Q2, Q1, Q0. Okay, serially means it will take 4 data, so 4 clock pulses to load the data. And at what time? Means at what time the parallel out operation is happening. Okay, at fourth clock pulse. Okay, at a time we are taking the data. Okay, at fourth clock pulse, you will get a Q3, Q2, Q1, and Q0 equal to what? 1, 1, 1. Okay, so in SIPO, how many clock pulses are required to get the parallel out? Okay, so 2n clock, not 2n, n clock pulses are required. N clock pulses are required to get the data out. Okay, are required, are required to get the data out, to get the data out. Okay. This is nothing but SIPO. Okay, serial in parallel. Okay, SIPO. Okay, is it fine? Any doubt in this? Any queries? Shall I move forward? Anyone?
Okay.
Okay. Mhm. Okay. Next you say this is SIPO, and next PISO. Okay. First. Okay. First we'll see parallel in parallel. Okay. Parallel in parallel out we'll see. Next we'll see parallel in serial out. Okay. Parallel in serial out. Okay. Parallel in parallel out. first we'll see the parallel in serial out. Next you can understand parallel in parallel out easily. Parallel in serial out. Okay. Parallel in serial out means what? There is a data means we can load the data. What we can load the data parallelly, and we can shift the data serially. Okay, load the data parallelly, and so that means parallel. So input is what parallel, and out out is what serial. Out is serial. Okay, so here what I will do. So I'll draw the four flip flops. Here this is D3, Q3, D2, Q2, D1, Q1, D naught, Q naught. Okay, this is connected like this. Okay, and here D3, there is a line. So common clock is given, as this is synchronous sequential circuit. Common clock is given. Common clock is given. Anyway, that is reset. Asynchronous active low reset is also there. So when asynchronous reset and you are giving, so when it is 0, it will be in reset mode, and when it is 1, that is a functional mode. That is given to clear signal of this shift register. Okay, so that also we can make. And next, here there is one more signal. That is what there is a signal called that is load by shift bar. Load by shift bar. Okay, so what is this load by shift bar? Or we can give like load by shift bar, or we can give a signal called load. Okay, we can give a signal called load. Okay, so this is load. Okay, so load means what? Like when load equal to when load equal to 1, this will data will be loaded. Data will be loaded parallel. Data will be loaded parallel. Okay, parallelly. And when load equal to 0, data will be shifted. Data will be shifted serially. Means what? When load equal to 1, it will do what? Parallel load operation. 4 bits of data at a time, parallel load operation is happening. And when load equal to 0, what operation it is doing? Shift operation it is doing. Shift operation. Shift operation I'm doing. Okay, so here I need to connect to what? I need to use one combinational circuit such a way that it is acting like a it's acting like one selection line, so that at a time any one of the input is connected. Can anyone say that a combinational circuit? Can anyone say combinational circuit? Which combinational circuit I need to use? Do you understand my question? Do you understand my question? Hello, hello, am I audible? Your response? Am I audible? No. Yes. Yes, I'm audible. Okay. Anyone? Here I need to connect one combinational circuit such a way that this is connected as a selection line. Selection line we already got in mux, no? Mux. So we can connect here. I can connect what? I can connect this one is what? I can connect 2 cross 1 mux. I can connect 2 cross 1 mux. Okay. This is acting as what? Selection line. Okay, load is acting as a selection line. So when load equal to here, this one I am connecting with what? 1. Okay, this one I am connecting with what? 0. Okay, this is connected to ground. So this I am connecting with what, D3. So when load equal to 1, load operation is happening, and when load equal to 0, shift operation is
Sir,
happening.
your voice is not audible, sir.
One second. Now is it audible? Give response. Is it audible? Yeah. Hello. Give response so that I will move forward. Anyone give response? Waiting for your response. Hello. In chat box, you message. Hello. Sai, am I audible? Shravani ma'am, am I audible? Now am I audible?
Yes, sir.
Okay. Yeah. See here, this one I am connecting with what, connecting with this uh, 2 cross 1 mux. Okay, 2 cross 1 mux I am connecting. Okay, so when I am connecting with 2 cross 1 mux, here what happens, this is acting as what, this is connected to 1 and 0. This load bar is connecting as a selection line. This load signal is there, no, load is signal is connecting as a selection line. So here I am giving D2, and this Q3 I am giving it to this 0 pin, and this output is given to D2. Okay, and next here also I am using one mux. Okay, this is 1 and this is 0, and this is what, D1, and Q2 is connected to 0. Okay, I0 and I1, whatever the selection line is there, I am connecting with this load signal. Okay, and next here also you see, so I am connecting a mux 1 0, and this is D0, and this is connected to Q1, and this output is connected to D0. Okay, and here you are getting the output Q0. So here what happens, when load equal to 1. Okay, when load equal to 1, what happens, load equal to 1, whatever the data is there, that is parallelly loaded. Okay, parallel load operation is happening. And when load equal to 0, so parallel load means what, parallel load means directly this will be connected, this D1 and D0, this will be connected. Okay, so this will be loaded into this all the registers. Okay, all the all the flip flops, the D flip flops, this will be loaded. Okay, so when load equal to 0, shifting operation is happening, means SISO, we already, serial operations we already seen, no. Okay, so what happens, we'll analyze this circuit with this table. Okay, so here if you see, so here this is a parallel and serial out, no. Where I should draw the diagram. Okay. Hmm. Okay. So here I am drawing the diagram. Just uh, clock. Okay. Parallel load. I'm drawing this. Okay. So here you see clock. Next Q3,
Q2, Q1 and Q0. Okay, so when clock is not applied, okay, so when clock is not applied, what happens, the content of all the output of the flip flops will be what, 0 only. Okay, you are not applying clock, just you are applying the reset. Okay, this is clock. Okay, and this is load signal. Okay, so that means what happens, all the outputs of the flip flops will be 0 only. And when you are applying like first clock, so during the first clock, what happens, load becomes 1. Load becomes 1. So load becomes 1 means which operation? Parallel in. Parallel in operation. So parallelly you are inputting the data. Okay, so when you are inputting the data, what happens, so here all these are connected, these ones are connected. Okay, so whatever the data present in this, let us take the data will be 1 1 1 triple 4 ones I will do. Okay, 4 ones means what, at first clock pulse what happens, all ones you will get, all ones you will get. Okay, at first clock pulse all ones you will get. Okay, and at the second clock pulse what happens, at second clock pulse, shifting operation is taking place. So that means here this will be shifted, so that means this becomes 0 and this becomes what, this becomes 1 second, this becomes shifting operation. Shifting operation means this will be loaded with what, 0, whatever the vacant position is there, that will be loaded with 0. And this one will be shifted. Okay, this one will be shifted. Okay, so 1 second, this one will be shifted. So this one will be shifted, here you will get 1, and this one will be shifted, here you are getting 1, this one will be shifted, here you are getting 1. Okay, so at second clock pulse, what happens, whatever the vacant position is, that will be loaded with 0, and here you are getting 1 1 1. Okay, a third clock pulse, what happens, a third clock pulse, so see here, so this will be shifted and this vacant position is loaded with 0, and here you are getting 0, this will be shifted and 1 will be shifted here, this one you will get here, and this one you will get here. Okay, so you are getting what, 0 0 1 1 you are getting. Okay, at fourth clock pulse what happens, at fourth clock pulse, so at fourth clock pulse, so the vacant position is loaded with 0 and this will be shifted, here you are getting 0, this will be shifted, here you are getting 0, and here you are getting 1. Okay, so here you are getting 0 0 0 1. Okay, and at fifth clock pulse, okay, at fifth clock pulse, so what happens at fifth clock pulse, so this vacant position is loaded with 0, and this way this will be shifted, here you are getting, and this will be shifted, this value you are getting here, and this will be shifted here again. So content of all the flip flops becomes what, 0. Content of all the flip flops becomes 0. Okay, so like this it will do the PISO operation, parallel in serial out. Okay, so PISO, so at what time, okay, at what clock cycle, okay, at what clock cycle the content of all the output of the flip flop becomes 0 means you can write n plus 1, n plus 1. At fifth clock pulse what happens, the content of all the flip flops becomes what, 0. Okay, so at 2n plus, so if you take the n bit flip flop, so so how much clock pulse the content becomes clear means it becomes n plus 1. Okay, so this is nothing but what, serial in parallel route. Okay, SIPO, parallel in serial route, parallelly you are loading the data and serially you are taking out the data. Is it fine? Shall I move forward? Yes or no? Any?
Yes, sir.
Okay.
Yeah, sir, only for this it will take 5 clock cycles. Other operations only 4 clock cycles,
Yes,
right?
yes, yeah, yeah. Only for this at fifth clock pulse, so what happens? The content of all the registers becomes 0. All content of all the flip flops, D flip flop becomes 0. So that's why from this only I am going to find out the clock cycle for general n bit flip flop. That means here you are taking four flip flops means how many clock cycles? 5 clock cycles. Here for n bit shift register you will get n plus 1. Is it fine?
Yeah, got it, sir.
Okay, okay. Next you see. Next is last one. What is that? PIPO. Parallel in parallel. PIPO. Okay. PIPO. PIPO means what? Parallel in parallel out. Parallel in parallel out. So here also we are using 4D flip-flops. Okay, 4D flip-flops we are using. So basically D flip-flop is a sequential buffer. So basically for the registers we will use this D flip-flops. Okay, but for the counters we can design by using D flip-flop also, but some more additional circuitry is required. That's why we are using JK flip-flop and T flip-flop, that two operating in toggle mode. Okay, so D3 Q3, D2 Q2, D1 Q1, D0 Q0. Okay, D0 Q0. So here so here what you are doing, like this. Okay, parallel in, parallel out, no, parallel in, parallel out. Okay, so here I am using common clock for all the flip-flops. Common clock for all the flip-flops. Okay, parallel in, parallel out. Okay, so here I am using one more signal, that is load by load signal. Okay, so load signal is connected with the mux only. Okay, here I am using mux. Here also I am using mux, 2x1 mux. This is very easy. Parallel in, parallel out. Parallel in, parallel out means what? You are you are sending the data parallelly. Okay, so you are loading the data parallelly and you are taking out the data parallelly. Okay, so here I am using this signal. So this is load. Okay, so I already told you, when load equal to 1, it will do which operation? Load operation, no? So this only I am using, load operation, parallel load operation I am using. Okay, so parallel load means it is connected to what? 1 0, and here also 1 0, I0 and I1. Okay, 1 0 and 1 0. Okay, so this D3, D3 is connected to input I1. Okay, D2 and D1 and D0. Okay, D0 I connected. Okay, and after that this I0, this first signal is anyway connected to ground. Okay, so this is connected to ground, and this output is given to this input. This output is given to this input, and next Q3 is given as a input. Okay, 1 second. Q3 is given as a input. Here Q3 is given as a input, and next this output is given, and Q3 is given as an input, and this output is given, and Q3 is given as input, and this output is given as this output to the D0. Okay, and what I am doing, I am taking the Q3 at a time. Okay, Q3 at a time. So that means from here I am taking the data parallelly. From Q3 I am taking the data, Q1 I am taking the data, Q0 also I am taking the data. So here I am getting the parallel data, Q3, Q2, Q1 and Q0. Okay, Q3, Q1, Q0. So that means number of clock pulses. How many clock pulses? When load equal to 1, parallel load operation is happening. Parallel load operation is happening. Okay, parallel load operation. And so during so number of clock pulses, how many clock pulses are required? Number of clock pulses within one clock pulse. Within one clock pulse, what happens? Whatever the data is there, that will be loaded. Whatever the data you want to load, suppose within one clock pulse, let us take data, 4 ones are there. So 4 ones will be loaded by using this control signal. Okay, load signal. After that, so first clock pulse, the data will be loaded. Okay, and during that same clock pulse, you are taking out the data at a time you are taking out the data. Okay, you are taking out this data, 1 1 1 1. Okay, so 1 1 1 1 you are taking out. So that means how many clock pulses are required? Means one clock pulse is required. Okay, so this is nothing but PIPO. PIPO means what? Parallel in, parallel out. Parallel in, parallel out. Is it fine? Any doubt in this?
Okay, sir. No doubt.
No doubt. Okay, okay. So this is about PIPO, PISO. Okay. Mm, one second. Yeah, yeah. Remaining counters, one more ring counter and Johnson counter is there. That we will discuss in the next class. Okay. Yes.